I'd like to show you something in JUMP to verify some of the work we were doing by hand. Uh, if we look at a 2-cubed full factorial design and cram two more factors in it, one d equal ab, e equal ac as the generating relations, we argued that that produces a defining relation of I equal abd equals ace equals bcde. And I'm using colons here instead of equals to denote the fact that those columns would be lined up the same. And then furthermore, if you take this row, multiply through by A, you get A, BD, CE, ABCDE. With B, it's AD, ABCE, CDE. AB, we just get D, BCE, A, CDE. With C, then it's A, B, C, D. Goodbye C from ACE and BDE, AC. We'll get BCD, we'll get just E, and we'll get ABDE, and so on. So are these right? Well, I want to show you a file that just kind of reinforces what we were up to previously. Here's a jump file I created. It started off with 8 columns. I added some other ones. Let me just tell you what we have here. This is column of all ones, call that I. Here's the column A with minus, plus, minus, plus, minus, plus, minus, plus. B, 2 minus, 2 plus, 2 minus, 2 plus, and C with 4 minus, 4 pluses. If we only had those 3 factors, this would allow us to run a 2-cubed full factorial, take it from there. With a full factorial, we would then be able to estimate unambiguously AB, AC, BC, and ABC. That's what we were doing with the full factorials. But what if we want to, as indicated on the PowerPoint slide, have both D and E in this model? So if we set D, say, equal to AB, I've already computed it, AB, you see this is the same as AB, 1, 2 minus a plus, plus 2 minus a plus, plus 2 minus a plus, plus 2 minus a plus, and E, we look at that with 1 minus, with plus, minus, plus, minus, minus, plus, minus, plus. That's the same as AC, plus, minus, plus, minus, minus, plus, minus, plus. Check the formula. See, it's AC. I've already computed it. Now, with DE in the model, we're still interested in the various other effects. And so we have, for other effects, we have AD, BD, CD, ABD, ACD, BCD, ABCD. We have the E, ones involving E, AE. Let me move it over. AE, BE, ABE, CE, ACE, BCE, so on, all the way down to ABCDE, and you see there's 32 columns here. Now I'm going to check, I want to use JUMP to determine which of these columns are the same. One quick way to do it, which is doesn't show it directly, you have to understand what's going on, but if we do a analyze multivariate, include all of our columns, this might be the easiest way to do it. This computes a correlation matrix, and you see under A, we have BD, CE, and ABCDE. With B, we have B itself, of course, AD, ABCE, CDE, and so on. So this gives us a quick way to check what all is confounded with what. Let me put this on a green here. And so we can, do a kind of a verification as to what's going on. What effects are confounded with what other effects? Okay, so let me go back to the way that I had in mind, just to basically compare the columns head to head. And to do that, what I want to do is effectively transpose all these columns. Do that first. This is kind of jump stuff, so that's I'm putting on on a video. Transpose all the columns. All right. And then, so these are, as you see, I column is all plus ones. A is minus plus, minus plus, minus plus, minus plus, so on, all the way down to the A, B, C, D, E. Okay, let's find those rows that are same. Well, we could do that by sorting the whole table. Table sort by all the rows. And one thing we might do to get I at the top is if we highlight them and then largest to smallest, so that'll be the one off the bat. And so do OK. Just going to give us a new table, 292. And you'll see that we have a group of 4 here that are all the same, all ones. And then for this next one with the BC column, we pick up 3 more. With the AC column, pick up 3 more. These are the rows that are absolutely identical. So let's group these. Put in a group formula. Do the count function. And say 1 through 8, 8, and repeat them 4 times. All right. And now we have them into these groups, so that tells us sort of how things are aligned. And now I have the labels associated with groups. I don't really need these guys anymore. Let's just highlight that one and this one. Tables subset. And just the selected columns. All right, now let's split this column by column 10. Table split. We'll split the label column by column 10, and that'll put it into those groups. There we go. Now we have them kind of lined up, I, A, B, D, A, C, E, B, C, D, to make it look exactly kind of like how we've been doing it in class. Let's do a transpose of this guy. Tables, transpose, all 8 columns, transpose. There we go. So now we have our defining relation I, A, B, D, A, C, E, B, C, D, E. And here we have the course. And we could rearrange these. I'm not going to do it. I'll just do one to show if you wanted to make it look just how you perhaps might prefer. Move rows. I can move that row to after row 1. That moves A up here. I can move B and so on. So anyway, that should verify what our exact design is. So let me stop it there.